Hello everyone, I am Shiva Soumya. My seminar topic is an IoT-based smart healthcare system using Raspberry Pi under the guidance of Dr. H. Girisha Sir, Professor HOD, Department of CSE, RIMEC. The contents of the seminar is as follows. Introduction. Smart healthcare system using IoT describes the collection and interoperation of patient data collected from the sensors from the hospitals through IoT technology. Now, what is IoT? IoT is the Internet of Things. The Internet of Things is the interworking of physical devices, vehicles, buildings, and other items embedded with electronics, software, sensors, and network connectivity that enable these objects to collect and exchange data. IoT can be used in monitoring patients' health parameters. The architecture for this system is based on medical sensors which measure patients' physical parameters by using wireless sensor networks. Here, we use sensors to collect the patient's data and transfer the data to the cloud environment using wireless networks. The data collected from the sensors will help the doctor during the emergency situations and for the better treatment for the patient health. Here, we use Raspberry Pi as an IoT device which helps in minimal cost for the program. The data which is collected from the sensors can be accessed by the doctors and patient guardians anywhere across the world because of the cloud technology we use. We use cloud because the cloud computing is general expression for any technological services provided through the internet. Cloud computing provides compatible and on-demand network access for numerous computing resources such as networks, systems, applications, and services. Moreover, cloud computing are using modern and flexible methods to provide, manage, and pay for information technology services with minimal management effort and cost. Cloud computing technology has several advantages such as flexibility, highly automated, low cost, fast services providing, and a huge storage capacity. The cloud's features enable customers to build, test, and deploy their applications on virtual services using different infrastructures on multiple operating systems. Objective. The objective of this system is how to monitor the patient with a minimal cost and to avoid delays in the information of patients to doctors during the medical emergencies, particularly in accidents. This system will help to stop the traditional manual entering of patients' data as the data can be accessed from the cloud itself. This system helps to increase beds capacity in hospitals, especially during the public events where the large number of people are meeting in one place, as the existing patients can be monitored from their place itself. Proposed system. We have proposed a system which is smart enough to collect the data of the patients automatically using IoT. This system collects various parameters of the patients such as patient's temperature, heart rate, ECG, blood pressure, and body movement of the patient. If these parameters, like as mentioned above, go wrong in any way, an alert SMS will be sent to the doctor and as well as the patient caretaker. Raspberry Pi will monitor the patients in this system. After connecting Raspberry Pi to the internet, it acts as a server. This will send data automatically to the website, and by using the IP address, anyone can access the data of the patient anywhere in the world using smartphones, laptops, and tablets. This is the block diagram of this proposed system. Here, the Raspberry Pi is connected to the 5 sensors as shown in the diagram. The Raspberry Pi acts as a monitoring system which is connected over an internet and a cloud storage. Here, the doctor and the caretaker can access the cloud storage, which contains the information of the patient. Methodology. Here, the IoT device is the Raspberry Pi. The sensors will collect the patient's health parameters. The readings and the information collected from the sensors will be converted into a form of signals. These signals are sent to the Raspberry Pi, which is an IoT module. This Raspberry Pi will display the readings of the patient on a monitor and stores the data over a cloud. If there is any wrong in the parameters, then an mail is sent to the doctor in an emergency situation where the immediate medication is required. The diagram shown next is the flowchart of the system. Here, the flowchart for remote patient monitoring system is shown. Devices in implementation. Raspberry Pi. Raspberry Pi is an IoT device. Raspberry Pi is credit card sized computer and it is a series of small single board computers. Here we use Raspberry Pi to collect the various parameters from the sensors connected to it. In this system, Raspberry Pi will help to display the readings collected from the sensors and helps to store the data over the cloud. The Raspberry Pi is a popular platform because it offers a complete Linux server in a tiny platform with a very low cost. Temperature sensor. This sensor will help to record the temperature of the patients in this system. We use this temperature sensor to record the patient's temperature series. Temperature sensor is one wired sensor that can measure temperature with a minimal amount of hardware and wiring. This sensor uses a digital protocol to send accurate temperature readings directly to the development board without need of a digital to analog converter. Heartbeat sensor. This sensor is used to measure the heart rate of the patient. Heart rate is the speed of the heartbeat measured by the number of contractions of the heart per minute, which is known as BPM. The heart rate can be vary according to the body's physical needs, including like maybe absorption of oxygen and excretion of carbon dioxide. If there is any abnormalities in these recordings, the doctor will receive a mail regarding these parameters immediately. Accelerometer sensor. Accelerometer sensor gives a digital output 3-axis accelerometer whose low power consumption and built-in features make it ideal for use in a wide variety of applications. Here, we use this accelerometer sensor to measure both position and movement of the patients. If there is any abnormalities seen in the position as well as the movement in the patient, this sensor will give an alert. Blood pressure sensor. Here we use this blood pressure sensor because it helps to record the blood pressure of the patients. Blood pressure sensor is a sensor designed to measure human blood pressure. It measures systolic, diastolic, and mean arterial pressure utilizing the oscillometric technique. ECG sensor. Here we use ECG sensor to collect the ECG status of patients. ECG sensor is the process of recording the electrical activity of the heart over a period of time using electrodes placed on the skin. These electrodes detect the tiny electrical changes on the skin that arise from the heart muscles, electrophysiological pattern of depolarizing during each heartbeat. It is very commonly performed cardiology test. Hardware setup. This is the hardware setup for remote patient monitoring system using Raspberry Pi. Here, we implemented the system by using all the sensors as mentioned above, connecting it to a Raspberry Pi. Benefits to the society or organization. This system will be useful to the hospitals as well as the patients. This system is useful for the hospitals and clinics because it produces the real values and parameters of the patients in real time. From this system, doctor can check the patient's body temperature, ECG, heart rate efficiently from the patient's house itself rather than being in the hospital. The patient's data parameters can be accessed by doctors and the caretakers anywhere around the world. This system even helps the patients in the cost reduction as this system will help in the expenses of bed, reducing in expenses of bedding in hospitals, as the monitoring can be done in their house itself. Future scope. Future scope to this system can be that the camera can be added to this system, because in the present system the camera is not added. For monitoring the patient, camera is a added advantage too. So adding a camera to monitor the patient, this will be helpful. And we can plan to enhance the functionality of the system by adding more sensors and using it to collect data from a larger sample size of patients. Conclusion. I want to conclude it by saying that this system is useful for both the hospitals as well as the patients, because the integration between wireless sensor networks and cloud computing will create a new generation of technology in many aspects, such as patient monitoring with minimal cost, in reducing the number of occupied beds in hospital, and improving medical staff performance. This proposed system gives better and effective healthcare services to the patients, and the information collected is networked worldwide through internet and communication devices, in turn connected to cloud services, and doctors can use this data and provide a quick and effective solution in emergency situations. References. These are the references I have been referred with. Thank you.